Hi everyone. So in the previous video classes we have learnt about classification of carbohydrates, that is saccharides. So we have learnt about different types of sugars. So now we are going to learn about one particular saccharide, that is monosaccharide, glucose. So we are going to learn about glucose in detail regarding its structure. Now once you start with glucose, first you should remember what is the molecular formula for glucose. So what is that molecular formula for glucose? We can write it as C6H12O6. So it is one of the monosaccharide which cannot be further hydrolyzed. So now this glucose, it is rich in different types of fruits. Whatever the fruits you are going to eat, they contain glucose as well as fructose. So we can find abundance of glucose as an organic compound in different fruits. Now once you consider one particular fruit, that is grape sugar. So now we can consider that grapes are abundant, are rich in this glucose. So grapes, of course, they contain both glucose as well as fructose. You know that there will be abundance of this glucose in the grapes. And now we can give that name for this glucose as grape sugar because of its abundance in the grapes. And once you come for our blood, that is, human being cannot survive without glucose. So that means to maintain energy profile in our body, to get activated. So we need energy. So that energy is obtained with the help of the glucose. So glucose is acting as energy booster for us. So without glucose we can't survive. If there is a decrease in the glucose, that is blood sugar level, so it is causing us to decrease in our biological activities. So we need to maintain the normal proportion of the glucose in our blood. So now we can call that glucose as blood sugar also, because our blood contains sugar. Which is that sugar? That is glucose. And now if you come for that preparation part, so we have to learn how we are going to prepare this glucose. So how we are going to synthesize this glucose. Now let me give, there are two methods for the preparation. So I am going to explain that. So very first method of preparation, that is from sucrose. Do you know what is that sucrose? Sucrose comes under disaccharide. So because it is made up of two monosaccharide units. Which are those two monosaccharide units? One is glucose, another one is fructose. And now if you consider that sucrose, which is rich in sucrose, so that sucrose is abundant in cane sugar. So now we can synthesize or prepare glucose by starting with that source. Which is that source? Cane sugar. So cane sugar contains disaccharide, that is sucrose. So what is that formula for sucrose? So we can write it as C12H22O11. When sucrose is subjected for hydrolysis, then you are going to get the splitting up of disaccharide units to give monosaccharide units. Of course, we can subject this cane sugar or sucrose for hydrolysis in the presence of dilute HCl or dilute H2SO4. So you need acidic medium. So in acidic medium, it is helping for the breakage of the bond between the two saccharide units which are present in the sucrose. Hence, you are going to get two monosaccharide units. Which are those two monosaccharide units? One is, that is C6H12O6. So C6H12O6. Here I am writing the same formula, but here we can consider one is called as glucose and another one is called as fructose. This is how you are going to get the formation of glucose, that is prepared by the hydrolysis of sucrose. And now if you go for, that is starch. So even we can prepare the glucose starting with the starch. So now once you start with the starch, so do you remember starch belongs to which type of saccharide, which type of sugar? So it is helping for the structural formation, that is one of the structural unit present in the plants. Not structural unit, it is one of the storage polysaccharide in the plants. So now if we come for that storage polysaccharide, that is starch, which is present in plants. And now we can start with that same starch C6H10 O5. This is on treating with dilute H2SO4. On treating with dilute H2SO4. Dilute means there will be presence of aqueous medium. And we have to maintain the temperature 393 Kelvin and 2 to 3 atmospheric pressure. So, under these conditions, this starch is going to split up into glucose units. You are going to end up with the formation of glucose C6H12O6 because starch is one of the polysaccharide which contains repeated glucose units. So, hence, there will be breakage of the bond between these polysaccharide which contains purely glucose units, which is easy to obtain the glucose. That is how we are going to prepare that glucose, either starting from sucrose or starting with starch. So, that is regarding preparation of glucose. Once you learn about preparations, then now we can directly go for one of the important topic. So, that is elucidation of structure of glucose. So, we have to give one exact specific structure, relevant structure for the glucose. For the first time, the open chain structure was given by the scientist by name Fischer. So, now we are going to learn about that analysis regarding the structure of the glucose that can be considered as elucidation of structure of glucose. So, that is particularly open chain structure for glucose. Elucidation of open chain structure. Open chain structure of glucose. So, now we know that glucose, it comes under monosaccharide, but there should be someone to give that exact structure for glucose, right? So, that was done by the scientist by name Fischer. So, he was able to conduct many different types of reactions. By observing the chemical properties of glucose, he was able to give one particular structure for the glucose that was called as Fischer's open chain structure. Now, once you go for this elucidation of open chain structure, elucidation, that is analysis regarding the structure of glucose by considering step-by-step reactions. Now, very first, if you start with glucose, you know that molecular formula for glucose is C6H12O6. By elementary analysis and molecular mass determination, he was able to give that molecular formula for glucose as C6H12O6. That means that formula, molecular formula was given as C6H12O6. It was given as C6H12O6 by the help of elementary analysis, that is, which are the elements which are present in the given organic compound that is considered as glucose, that is elementary analysis, and even by considering molecular mass determination. One by considering elementary analysis and another one by molecular mass determination. He was able to give that exact molecular formula for glucose as C6H12O6. By considering this molecular formula, next he can go for which are the functional groups might be present in that glucose. So, he was just getting idea there might be presence of aldehyde group or there might be presence of carboxyl group, but he want confirmation whether it is containing carboxyl group or it is containing any carbonyl group like aldehyde or ketone. So, he want confirmation for that. So, what he did? So, we can go for one of that reaction what was observed by himself, that is when glucose was made to react with any particular reagents, that is we are going to learn about functional group analysis. Functional group analysis. once regarding this functional group analysis, so he has to decide whether it is acidic in nature. If it is containing carboxyl group, it will be acting as acidic in nature because of this carboxyl group. And now, of course, whatever the observation was done by scientists, so very first observation, when glucose was made to react with sodium bicarbonate, NaHCO3, he was not able to observe any effervescence. That means he was not able to get any type of reaction. No reaction takes place between glucose and sodium bicarbonate. So that consider that glucose will be neutral in nature. It is not containing, this observation confirms him that it is not containing carboxyl group. So that is COOH group. Now in case if it is containing carboxyl group, it would have given effervescence as observation. That effervescence will be due to the release of the carbon dioxide. That means in case if glucose would have contained carboxyl group, it would have reacted with sodium bicarbonate to release carbon dioxide carbon dioxide gas, which gives effervescence. So that means it proves that glucose is acting as neutral in nature because of absence of this carboxyl group. And nextly, that is regarding same type of, that is a functional group analysis. Under this functional group analysis itself, he was able to conduct further different types of reactions. Under that, we can consider when glucose, that is regarding detection of carbonyl group. So for the detection of carbonyl group, he was able to conduct the reaction for glucose. One is glucose, he was able to make reaction between glucose and other one hydrogen cyanide, and glucose along with sodium, that is ammonium hydroxide, NH2OH. Now we are going to learn about those set of reactions. So in the very first functional group analysis, he considers that there is no carboxyl group present in the glucose. In the very next step, he did experiment, that is between glucose and hydrogen cyanide. Now we have to write the structure for glucose. So let me write it as, just we know that aldohexoses, that is glucose, it is aldohexoses. Let me write terminal here CHO, and I will write it as CHOH 4 times, and finally I will write primary alcoholic group, that is CH2OH. Now let us consider, so this glucose, when he made glucose to react with hydrogen cyanide, HCN, hydrogen cyanide. What is that type of reaction taking place here? As you know, this hydrogen cyanide can interact with this CHO group, that is aldehydic group. So when HCN interact with CHO, how it is going to interact with this HCN? As you know, I can write there will be presence of C double bond O and here H. This bond is shifted towards more electronegative oxygen atom here. So it is getting a negative charge. HCN can dissociate to give H plus and Cn minus. Now O will easily get attached to H, so that you will get the formation of OH group here. So I can write it as CH, and right hand side I will write it as O is attached with H, OH. And now this carbon atom, which is electron deficient center, there is attachment of this nucleophile Cn minus. So we can get that addition of Cn. Now we can write the remaining possibility. It will remain as it is, CHOH 4 times. Then let me write CH2OH. Now glucose on reaction with hydrogen cyanide, you are going to get one of that product. It is called as glucocyanohydrin. What it is called as? Glucocyanohydrin. Glucocyanohydrin. So it is obtained by the interaction of aldehydic, specifically aldehydic group with hydrogen cyanide. This indicates that there might be, he will come to the conclusion that there might be presence of carbonyl group similar to that of carbonyl group. Here glucose is also interacting with hydrogen cyanide to give glucocyanohydrin. So it gives the indication for him that there is presence of carbonyl group similar to that of HCN. Then even he was able to give another reagent. So which is that reagent? So we can write one of that base NH2OH. NH2OH. When same glucose was made to interact with, or when glucose is treated with base, that is ammonium hydroxide, NH2OH. Now once we can consider this aldehydic group, again it is reacting with this base, it is able to interact with oxygen, particularly there will be removal of oxygen along with this hydrogen. Now oxygen will react with hydrogen, that is H2, it will be removed off in the form of water. And now for this double bonded carbon atom, there is direct linkage of nitrogen along with hydroxyl group. That is how we can get glucose oxime. Glucose oxime, when glucose is interacting with NH2OH, then we can easily consider there will be removal of oxygen. In that case, we can write double bond, then there is attachment of double bond N, single bond OH. Double bond N, single bond OH. Now once you can consider here carbon atom which is bonded towards oxygen atom through double bond here. Now this oxygen atom is removed off along with this hydrogen in the form of water molecule. So now we are going to attach that with this nitrogen. Hence we are going to you are going to get that product that is called as glucose oxime. Glucose oxime. So this is that product which is obtained by the interaction of glucose with this base, that is NH2OH. Now once you get this glucose oxime, by this reaction he will get indication that there is once again it proves that there is presence of carbonyl group in the glucose. By considering interaction of glucose with hydrogen cyanide and glucose with this NH2OH, he was able to get the products. By the help of these products, he will confirm that there will be presence of carbonyl group in case of glucose. That is particular functional group we have to consider which is that particular carbonyl group by considering another set of reactions. Now once he proves that there is presence of carbonyl group, then he have to prove that whether it is aldehyde or ketone. Then for that he should go for other set of reactions. For the confirmation of the CHO group present in the glucose, he was able to conduct one more reaction. So which is that reaction? So he was able to conduct that reaction which includes glucose will react with bromine water. Glucose will react with bromine water. That means he will conduct oxidation in the presence of bromine water. So on oxidation in the presence of bromine along with water, that is called as bromine water, so which is acting as mild oxidizing agent. So when glucose was made to undergo oxidation by the help of bromine water, only this terminal aldehydic group will undergo oxidation and it will convert into COOH group. Now we can write the same remaining will be as it is. There will be no change. CHOH 4 times and here CH2OH 4. Now what is the product name? So here glucose on oxidation with bromine water, it will convert into gluconic acid. So that means gluconic acid will be Nothing but the same, remaining structure will be one and the same with respect to glucose. It is differing only with this first carbon atom. Here in glucose there is aldehyde group, but in gluconic acid there is carboxyl group. So that is how he was able to prove that there is presence of aldehyde group in case of glucose. So that means after considering that functional group present in the glucose, it is carbonyl group, and then that specifically that carbonyl group is aldehyde group but not the ketonic group. And after considering the presence of aldehyde group, even you need to prove that there are hydroxyl groups present in the glucose, and how many hydroxyl groups are present in the glucose. That was proven by another set of reaction. Which is that reaction? He made glucose to react with or interact with acidic anhydride. So, on reaction of glucose, CHO, CHOH, then CH2OH. When glucose was made to react with acetic anhydride. What is the formula for acetic anhydride? CH3COO CO CH3. So when he make that reaction glucose on interaction with acetic anhydride, either you can write it as CH3COO CO CH3, or you can write it in this format CH3CO twice O. This is also considered as acetic anhydride. Now we can see here why I have written this. You will come to know that interaction is possible between hydroxyl groups and this acetate group. So here we can break the bond between CO and O, so that here hydrogen atoms belonging to the secondary carbon atom and primary carbon atoms, they will get attached with COO group, that is resulting in the formation of acetic acid. So there is conversion into carboxyl group, and that remaining CO group, it will get attached to this carbon atom and result in the formation of acetate group. So you are going to get CHO, it will be as it is, and I can write it here CH, CHO. Then CO group will get attached along with this CH3. We can write CO, CH3. That is why we can call it as acetate group. So here how many totally acetate groups? 4. And even we can get one more acetate group, that is CH2O CO CH3. Totally how many acetate groups you are going to get? 5 times. That is 4 plus 1 5. Hence the name for this product is glucose pentaacetate. Glucose pentaacetate. So with the help of this reaction, he was able to give the confirmation there will be presence of aldehyde group. That is terminal aldehyde group will be present in the glucose. So that is regarding the functional group analysis, which is belonging to the glucose, which is that functional group, that is exactly aldehyde group. Now, once you can guess, after learning about carbon which is containing, that is glucose which is containing aldehyde group, then hydroxyl group, then one more we can consider, that is primary alcoholic group. Now we have to prove that even glucose is containing primary alcoholic group. Next, another set of reaction, that is regarding presence of primary alcoholic group. Primary alcoholic group. So which type of reaction you will consider? So he just made glucose to undergo oxidation in the presence of strong oxidizing agent, which is that is HNO3, nitric acid. CHO, CHOH, then CH2OH. When glucose was made to undergo oxidation in the presence of nitric acid, HNO3, nitric acid, it is a strong oxidizing agent, so that it will oxidize both aldehydic group as well as this primary alcoholic group. So hence he was able to get that product. CHO is converting into COOH, that is carboxyl group. Again CHOH, it will be as it is 4 times, and even last, that is COOH. COOH. That means you are going to introduce carboxyl groups into the glucose. There is conversion of terminal aldehydic group into carboxyl group and terminal primary alcoholic group into carboxyl group. It proves that there is presence of terminal, that is primary alcoholic group. So it gives the confirmation that glucose contains terminal aldehydic group as well as terminal alcoholic group, that is primary alcoholic group. So what is the name of this compound? It is called as saccharic acid. Saccharic acid. So now we can consider, he will just prove that there will be presence of aldehydic group, there are hydroxyl groups present attached, that is hydroxyl groups attached to the carbon atom. Other than this carbon, terminal carbon atom, remaining carbon atoms are containing hydroxyl groups, and even he will consider that last terminal primary alcoholic group is also present. And he will consider one more reaction, that is very simple reaction. By that he was able to give that glucose will be having open chain structure, that is done by reduction process. When so carbon, presence of carbon parent chain, so which proves that which will be having open chain structure. Now we can consider glucose, CHO, CHOH, CH2OH. When glucose is subjected for reduction, when it is subjected for reduction, in the presence of that, reduction will be done with the help of the red phosphorus and hydroiodic acid or hydrogen iodide. When you consider the mixture of red phosphorus and hydrogen iodide, you are able to get H3PO4 and H3PO3. They are helping as reducing agents. So by the interaction of these two, they are going to help the reduction of these carbon atoms, so that he was able to get hexane, CH3, CH2, 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 1, 2, 3, 4, 5, and lastly CH3. That is nothing but called as N-hexane. Once he will observe that there is formation of N-hexane, he will consider that glucose will be having open chain structure. Now, by considering all these reactions, set of reactions, even by observing other properties by Fischer, he was able to give one specific structure for glucose. So which is that specific structure? I am going to write it now. In case if glucose is having how many carbon atoms? 6 carbon atoms. Six carbon atoms, right? So now we can write CHO. Then he was able to give this open chain structure. It will be specifically called as D plus glucose. D plus glucose. By observing the set of reactions, and even he will consider that important property So where you can consider there will be presence of hydroxyl groups. If another possibility, here you can find other than the CHO, each carbon atom is bearing only one hydroxyl group. In case if we consider if the single carbon atom is attached to two hydroxyl group, then it is said to be highly unstable. That is why he will consider that the confirmation that hydroxyl group will be attached to each carbon atom. That means each carbon atom is attached to only one hydroxyl group, as you can see here. So here CHO, it is the terminal functional group present. It is first carbon, second carbon, third carbon, fourth carbon, fifth carbon and sixth carbon. Now, after considering this open chain structure, I have written here D plus glucose. He was able to just name this isomer as D plus glucose, because if we consider this aldohexose, actually it is containing how many chiral carbon atoms? That is asymmetric carbon atoms. Do you remember what is asymmetric carbon atom? The carbon which is bearing four different atoms or groups. Now, which are those chiral carbon atoms? First one we can consider. So, second carbon atom, it is one different group which is different. It is also different. These combiningly are different. So, this carbon is attached to four different groups. Hence, it is chiral carbon. So, this is chiral carbon. This is also chiral carbon. This is also chiral carbon. And this is also chiral carbon. Totally, how many chiral carbon atoms are there? 1, 2, 3, 4. So, if there are four chiral carbon atoms, 2 power n, 2 to the power 4 is equal to 16. Totally 16 isomers are possible for glucose, but specifically he will consider D plus glucose as one of that isomer. And this D is given that symbol with the help of the related configuration of the D-glyceraldehyde. I am going to explain that later. And now here the name here he has given it as D plus glucose. So, by considering the following, that is different set of reactions, whatever I had explained, we can easily get that confirmation for open chain structure for the glucose. That is regarding open chain structure for the glucose. And if it is considered as open chain structure of glucose, now we can just consider the same set of that is representation of all the hydroxyl groups, hydrogen atoms along with the terminal CHO groups by projection formulae. So, how we can write it as? It is very simple. We can write this terminal CHO. In spite of writing carbon atoms, we can just draw one straight line. And in terminal position, we can write it as CH2OH. And remaining 1, 2, 3, 4 carbon atoms here to mention, we can just write dash lines 1, 2, 3, 4. So, now what shall I write it here? H, OH, then H, and here also H. Now, we can easily observe H will be opposite with OH. And OH will be opposite with H. We can simply remember, if it is H, opposite side OH. If it is OH, opposite side H. H, OH, H, OH. So, this will be considered as open chain structure. Fischer structure, open chain structure, projection formula for glucose. Now, if it is the projection formula, Fischer projection formula for glucose, then if you want to write the same formula for gluconic acid and saccharic acid, so what is that representation? So, let me write it. It is glucose. And another one I am going to write it for gluconic acid. In case of gluconic acid, CHO group will be undergoing oxidation to give COOH group. Then I can mention it as COOH. Then we can write the same straight line. We can mention 1, 2, 3, 4. I am going to write 4 dash lines that representing next carbon atom, second, third, fourth and fifth carbon atoms. Then let me write same representation H, OH, H, H. And in the last terminal position, you have to mention CH2OH. Then here what shall I write? I can write H, OH, OH, H, H, OH, H, OH. It is the representation for gluconic acid. Gluconic acid. Now you got the idea how we are going to represent the Fischer structure for gluconic acid with the help of the Fischer projection formula of the glucose. Similarly, one more structure you can remember, that is we got glucaric acid on interaction of glucose with strong oxidizing agent, that was HNO3. So here the terminal primary alcoholic group will also undergo oxidation. So let me represent that by projection formula. So here terminal position also COOH. Then you have to write a draw straight line. So 4 dashed lines. And lastly, even the CH2OH is undergoing oxidation. You are going to get 2 carboxyl groups at the terminal position, and remaining will be as it is H, OH, H, then H. And here opposite side for H, OH, for OH, H, H, OH, H, OH. This is how you are going to get the Fischer's open chain structure for glucose, gluconic acid, and it is saccharic acid or glucaric acid also we can call it as. So that is regarding open chain, elucidation of open chain structure of the glucose. So this open chain structure was given by whom? That is the scientist by name Fischer. Hence we can consider this structure as Fischer open chain structure or Fischer projection formulae.